The next architecture I'm going to talk about is publish-subscribe architecture. As you see, this is actually a diagram of how publish-subscribe architecture looks like. So, it's actually three main components in publish-subscribe architecture, which is the publisher, the event bus, or you can say the message broker. The message broker acts like a middleman or a middleware in this case, and also the subscriber. So, PSA can be actually defined as a messaging pattern where it's the sender of a message are called publisher, and the publisher do not specify directly to whom the message to be sent, which is to the subscribers. So the publisher just publish the message, and they don't know anything about how many subscribers are they, and they don't even know who are the subscribers. And same goes for the subscriber as well. They just have to express their interest on what they want to hear or what they want to know, but they do not know any knowledge about the publishers as well. Hence, the event bus, or you can say the middleware, acts as an intermediary or a black box that collects all the messages and then just forward it back to the subscribers based on what they want to know or an interest. So, before I'm going to explain to you or give you an analogy of how publish-subscribe looks like in the reality. Okay, given that you're in a zoo, okay, they consist of various type of animals. In this case, we have dog, cat, rabbit, horse. So, in the olden days, in the zoo, you only have a zoo owner and the animals, and and each of these animals only listens to one operations. For in this case now, cat and dog is sit, and rabbit and horse is jump. So last time, which is a tight coupling system, zoo owner have to actually communicate to every animals one by one in the zoo, and to actually ask them to sit or jump. And this is actually a very tiring and inefficient process for the zoo owner to do that. So what PSA does is actually to hire a zookeeper. So whenever the zoo owner wants the animals to perform some operations such as sit, he just have to mention to the zookeeper. So now the zookeeper just shout to all the animals to sit. So which animals that actually listens to this operation, which is sit, they will actually sit. So in other words, the concept of SOA is actually to create an abstraction for publisher and subscriber to communicate message between different system components without these components knowing anything about each other. So yeah. So now moving on to the types of subscription model, there are actually quite a number of different models, but now I have chosen topic-based, content-based, and type-based. So what topic-based is actually the events or the message are actually classified into topics, which is as subjects or such as the keywords. So this is actually similar to the concept of the zoo, where the animals only listens to a certain operations called sit. That's the topic name or the keyword. So this grouping, they group the messages based on the topic that they want to hear. So in content-based, the events are actually classified according to the properties of the notifications, and the subscribers is actually announce their interest based on the events, the properties of the events. For example, you actually can specify like constraints like more than or less than. I'm going to explain to you later on an example of content-based. And there's actually no concept of grouping these messages based on topics. There's no keywords because they always talk about the properties about it. And type-based is actually similar to content-based, but it's actually a subtype of it. So what it does is the events or the message are actually classified based on the types of the objects. So you can actually encapsulate based on the attributes and the methods. The subscriber actually express the event type by supplying a filter expression that evaluates the attributes on runtime. So grouping messages based on the type of the objects. So moving on to the strength of public and subscribe architecture. So it actually provides an abstraction for the publisher and subscribers. It means that they do know their existence, each other's existence, which is the publisher and the subscriber, and they are ignorant in the system topology. So each of them can actually operate normally regardless to one another. As for tight couplings architecture, a client-server paradigm, client cannot actually send a message to server if it's not running. And same goes for the server to client, where they actually both have to be on at the same time. So as for PSA, it's actually provides space decoupling, time decoupling, and synchronization decoupling, which means they don't have to know each other, they do not have to run at the same time, and publish and subscribe operations are not hold during the receive of notifications. So this actually adds modularity to a messaging system where you can actually do your own stuff, you can actually do whatever operations, and the broker actually sends the message to you. And you can actually allows to add new and break the services, means to subscribe the topic and also unsubscribe the topic. So the next major advantage is the simplicity and the flexibility of decentralizing implementation, as this enables the system to support a large number of client and huge number of data transfers. And it is a highly scalable architecture. This is because that due to loose coupling, the publisher do not have to directly talk to the subscribers. So what it does is actually the publisher just publish all the messages that needed to push it up to the broker, and the broker distribute these messages or events to the subscriber based on what they want to know or the area of interest. Moving on to the weakness of PCA, the weakness will be the potential loss of messages due to the events that needed to be pruned. Because the publisher keep on producing a large number of events and push it up to the broker, and the brokers might crash due to insufficient storage. So what it does is actually, before to actually send it out to all the subscribers, it actually deletes or prune these messages so that the system will not be overwhelmed. And besides, the PCA is actually designed to deliver message for a specified time, but then stops attempt to deliver it back. So there's actually no guarantees for message delivering, as the message stores for a long time, and also you cannot control the ordering of the message. On the contrary, it actually increases a latency in this sense, because you create another layer, which is the broker, the middleman, to send out messages among one another. One of the examples that can be found is actually the stock market, where actually the publisher sends out the feed, which is the stock prices, continuously to a broker, and then traders is actually uses this information to use as a basis to buy or sell stock. So the traders only listens to receive messages of feed based on what they want to know. So this information obviously contains the latest stock prices, and the traders actually register their interest to subscribe of what they want to know and receive the updates. So the traders, or you can say the subscribers, can actually unsubscribe or subscribe some sort of area of interest without the publisher know. So it's actually two kinds of operations that take into consideration, which is the push, where the publisher just actually push all the events and messages to the broker, and then the subscriber actually pull any information regarding of what they want to know. So this is actually similarly to the topic-based concept, where they actually listens based on the keyword they want to know. So hence, publisher can always constantly update their stock prices by pushing it to the event bus, and the subscriber pull the information or the tag, in other words. And the next example would be the wireless sensor network. Apparently, it actually uses PCA as a communication scheme. So publish subscribe in this case actually introduced as the intermediary node, which is the broker between the sensor nodes and the collection nodes. In this diagram, you can see that the P1, P2, P3s are the sensor nodes, and these are actually the brokers. And this S1, 2, 3 is actually the collection nodes, which is the users to receive these informations. So basically, this sensor nodes actually receives all measurements or maybe temperature or humidity of the weather and send it to the closest broker. So what this broker is actually, they process the data and filter based on the content. For example, temperature exceeds maybe 35 degrees Celsius into one category and all this kind of thing. So the flow convey to collection of nodes based on their interests. So basically the broker uses the store and forward concept so that the both parties do not know each other. They are create an abstraction basically. And they do not have to be timely synchronized. So for example, the sensor node sends the measurement at 2 a.m. and then the users can actually collect it anytime when they're on their phone. So just now remember I have said about the content-based content-based model, where they actually filter the messages based on the properties of the events. So what it does is the nodes actually gets the temperature sensors and publish 21 Celsius. So whoever the subscribers wants to know about the temperature, they actually can be received as a message. So maybe one of the subscriber only wants to know when the temperature goes down to 10 degree. So what it does is whenever any sensors actually publish 10 degree, the broker will send the message to the particular user who wants to know that the temperature is 10 degree. So the verdict. So there are actually systems that uses point-to-point connection that provides the similar function as PCA. But as the metric grows, the connection metrics grows even bigger. It's actually quite hard to maintain since the network becomes very complex. So in my opinion, the public and subscribe system takes a major place in this case by removing the complexity and unmanageable aspect of the network view. So since we already know that the system architecture is actually loosely coupled, so it can actually handle a large number of data transfer or amount of data transfer. Yeah. So there are actually many approaches to build a public and subscribe system, and they're actually quite there are actually trade-offs for every approach, and in terms of the quality of service. So for instance, the topic-based model actually are not expressive, and the content-based consists of higher runtime overhead since because it's too expressive, and then it actually takes a time to actually filter and actually to give it out or forward it to the subscribers. Thus, to actually the public subscribe architecture inherits the pros and cons of broken pattern.